Hello everyone. Let's look at analytical geometry. So this question is plus or minus 40 marks in your exam. So the way learners fail paper 2 now is worrisome. So in this video, I will take you through analytical geometry, which is divided into two parts. The first part that I will be discussing now will benefit both grade 11 and grade 12. So this part in the exam is usually plus or minus 20 marks. And then there is part 2, which is strictly for grade 12s. That I will discuss on my second video. But let me start here. So before you even attempt analytical geometry question, there are basic things that you need to know. There are basic things that you really need to know. So let me start. So number one, we have distance. So distance, okay. So unfortunately enough, in grade 12, formulas are provided. Unfortunately, in grade 11, they are not. So distance for any diagonal line, so is given by the distance formula is AB. If I'm looking for the distance of line segment AB, so is AB is equal to the square root of XB minus XA all squared plus YB minus YA all squared. So now you will be given the coordinates in the exam, so you can just calculate the distance. And then we also have a vertical line. So sometimes they will ask you to find the distance for a vertical line. So now if the line is vertical, so they will say, number one, the line is parallel to y-axis. Any line that is parallel to y-axis, that line is vertical. Number two, they will say it is perpendicular. My perpendicular is wrong. It should be out there. So it is perpendicular to x-axis. If they say line is perpendicular to x-axis, so that means that line is vertical. Number three, you will notice that the x value is the same throughout. If the x value or the x coordinate is the same throughout, there is no change in x. So that means that line is vertical. Now, to calculate a distance for any vertical line, if here is our line, so you see that x is the same throughout. So now, the distance for any vertical line, you just say y top. In this case, the point that is at the top is B. So it is YB minus YA. So there is no need to use distance formula if your line is vertical. You can just say y top minus y bottom. So we also have horizontal line. Now, if the line is horizontal, they will say in the exam, the line is parallel to x-axis. Any line that is parallel to x-axis, it is a horizontal line. Number two, they can say it is perpendicular to y-axis. Any line that is perpendicular to y-axis, it is a horizontal line. So now if the line is horizontal, you will notice that there is no change in y. So the y coordinate is the same throughout. So now if you look at this line here, you will notice that y at A, y at B, they are the same. So there is no change in y. So now, to calculate the distance for any horizontal line, you just say, if you are looking for the distance of line segment AB, you will say AB is equal to x right minus x left. So you look for the x coordinate at B, so at XB, minus XA. And then you will always get a distance for any horizontal line. That is number one. So you need to remember all these under distance. Number two, we have a midpoint. So now if you are given line segment AB, and then if you are given the coordinates of A, you are also given the coordinates of B, and the midpoint is not known, you are looking for the point in the middle, you can use the formula for midpoint. So the formula for midpoint, it is XA plus XB over 2, which is provided in your information sheet. And then for Y coordinate, you just say YA plus YB over 2. And then you will always get your midpoint. Sometimes in the exam, sometimes they will give you one endpoint, for example, the coordinates of A. They will give you the midpoint as well, so the coordinates of M, and then they will ask you to calculate the endpoint, the coordinates of B. So with this one, you can always split the midpoint formula. Let me start with X. X for midpoint is equal to XA in this case, plus XB, B that you are looking for, divided by 2. And then you will substitute your X value for midpoint. You will substitute your X value for A, and then you can calculate the X value for B, or the X coordinates of B. And then with Y again, you will do the same. Y for midpoint is equal to YA plus YB over 2, and then you substitute your Y for midpoint, and then you substitute your YA, and then you can calculate YB that you will be looking for. With this one, you also need to remember the properties of parallelogram. So remember, parallelogram can be a square, can be a rhombus, can be a rectangle. So now, diagonals for any parallelogram, they bisect each other. So if they bisect each other, so this midpoint is being shared by this diagonal and that other diagonal. So if this is A, B, C, D, so you need to know that the midpoint of AD is the same as the midpoint of BC. So diagonals bisect each other. They are sharing the very same midpoint. Now let's move to gradients. So under gradients, again, there is a lot that you need to remember here. Okay. Number one, if you are given a line segment AB, so the gradient, we denote gradient using small letter m. So the gradient of AB is given by change in y over change in x, and this formula is provided on your information sheet. So the gradient is given by YB minus YA divided by XB minus XA. The formula is there in your information sheet. There is no way that you are going to write the wrong formula. It is provided. So maybe in your information sheet, it is written as Y2 minus Y1 over X2 minus X1. So you can calculate the gradient using this formula, and sometimes they will give you the angle of inclination. So remember this angle here. Here is your angle of inclination. So this angle theta is always equal to gradient as well. So you need to remember that tan theta is equal to gradient, because sometimes in the exam they will provide you, let's say for example, they will give you this angle and say this angle is 45 degrees. So now for you to calculate the gradient of this line, you can just say tan 45 is equal to gradient. Now, what is tan 45? So tan 45 is equal to 1. So the gradient of this line is 1. Or sometimes they will give you, maybe you are given 135. Now, if you are looking for the gradient of this line, you just say tan 135 is equal to gradient. So now, what is tan 135? So tan 135 is equal to -1. So given the angle, you can always calculate the gradient. So also, when you have a gradient, so that means you can always calculate the angle of inclination. So if you do have a gradient, you can calculate the angle. Also, if you have the angle, you can calculate the gradient. And you need to remember, when you are calculating, let's say you are looking for an angle. So with this one, if you are looking for an angle, you can say tan theta is equal to 1 for this one. And then you find arctan of 1, so which is theta is equal to arctan of 1. And then you will get this 45. But if the gradient is negative, for example, the second one, if you have tan theta is equal to -1. So to find angle theta, you'll always say theta is equal to arctan of -1. And then if the angle is negative, if the gradient is negative, and then you'll always add 180. And then you will get an angle that is bigger than 90. Now, number 2, under gradient, you need to remember the properties of parallel lines. So if two lines are parallel, for example, if you have line AB, here is line AB, and the line AB is parallel to line CD. So two lines that are parallel, the gradients will be equal. So if lines are parallel, their gradients will be equal. So the gradient of AM, not the gradient of AM, the gradient of AB will be equal to the gradient of CD. So now that means here is the gradient formula. The gradient of AB is equal to the gradient of what? Of CD. Sometimes in the exam, they will ask you to prove that or to show that lines are parallel. So that means you will calculate the gradient of line number 1, then calculate the gradient of line number 2. And if the gradients are equal, and then you can conclude that those two lines are parallel. And again, so you also need to remember all the properties of the quadrilaterals. Because sometimes in the exam, they will tell you that the shape is it's a rhombus. So you need to remember, if you have a rhombus is a parallelogram because opposite sides are parallel. So the gradient of this side is always equal to the gradient of that one. Even here, the gradient of this side is always equal to the gradient of that one. Sometimes they will tell you that you have a square. So even with the square, you need to remember that opposite sides are parallel. Sometimes they will tell you that you have a rectangle. You need to remember that even with the rectangle, the opposite sides are parallel. Sometimes they will go further and give you the midpoint theorem. So remember the theorem that says if you have a triangle, if you have a triangle, and then let's say A and B are midpoints. Maybe here, let me just write C, D, maybe E there. So now if AE is equal to AC and EB is equal to BD, so that means any line that is joining two midpoints of a triangle is parallel to a third side and is half the length of the third side. So that means AB is parallel to CD. So now the gradient of CD here is always equal to the gradient of AB. That is a midpoint theorem. So you need to remember that midpoint theorem as well. So parallel lines, okay, gradients are equal. You need to remember the quadrilaterals. You need to remember the midpoint theorem. And then under gradients again, we have collinear. They will speak about collinear. Sometimes even if they don't mention collinear, but you will see collinear in your diagrams. So collinear. So if we say points are collinear, that means they lie on the same line. So A, B, and C are collinear. They lie on the same line. Now, if they lie on the same line, the gradient of one line is the same throughout, regardless where you measure it. So that means if I measure a gradient between A and B, and then again I measure a gradient between B and C, I will get the same gradient. So if the points are collinear, that means the gradient of AB in this case is the same as the gradient of what? As the gradient of BC. So now the formula, you can write this as the gradient of AB is the same as the gradient of BC. Now, sometimes they will ask you to prove that points are collinear. So if they ask you to prove that points are collinear, you will calculate the gradient of AB, then calculate the gradient of BC. So the gradient of AB will be the same as the gradient of BC. And then we also have perpendicular lines. So still under the gradients. So you also need to remember the properties of perpendicular lines. So remember, if they say lines are perpendicular, so these denote perpendicular lines. So now, if lines are perpendicular, so where they meet, the angle is always equal to 90 degrees. So now, if lines are perpendicular, the product now of their gradients is always equal to -1. So now, if the line AB is perpendicular to BC, that means the gradient of AB times the gradient of BC, the answer will be -1. So in the exam, if they ask you to prove that lines are perpendicular, you will calculate the gradient of AB, then calculate the gradient of BC, and the answer should be -1. And if the answer is -1, you can then conclude and say, therefore, AB is perpendicular to BC. Now, sometimes they will not say lines are perpendicular. They will say angle ABC is equal to 90 degrees. So if ABC is equal to 90 degrees, that means AB, the gradient of AB times the gradient of BC will be -1. The gradient of AB times the gradient of BC will be -1, and then we know that lines are perpendicular. Again, even here under perpendicular lines, you need to remember the properties of the quads. Sometimes in the exam, they will not tell you that lines are perpendicular, but they will give you a diagram and tell you that this is a rectangle. You need to know that corner angles of a rectangle are 90 degrees. So if corner angles of a rectangle are 90 degrees, that means the gradient of this side times the gradient of that one is -1. They will tell you that you have a kite. So if they tell you that you have a kite, you need to know that the diagonals of a kite, they intersect at 90 degrees. You need to know it because sometimes in the exam, the way they are so harsh, they will not write this 90 degrees here, but they will tell you that this is a kite. But if you know your properties very well, you will then know that, the gradient of this line multiplied by the gradient of that line will be -1 because the diagonals of a kite, they intersect at 90 degrees. Even with the rhombus, the diagonals, they intersect at 90 degrees. You need to know that. Now, if lines are perpendicular, look at this. This will save your time in the exam. Now, let's say, for example, you have these two lines. Okay, let me just say line 1 and line 2. This is line 1 and line 2. If the gradient of line 1 is 3/4, if line 1 is perpendicular to line 2, you must then know that the gradient of line 2, you just invert this or write a reciprocal. You will say it is 4/3 and you will change the sign. If the gradient of line 1 is 2, if the gradient of line 1 is equal to 2, remember 2 is the same as 2/1. So the gradient of line 2 will be, you just invert 2/1, it will be 1/2, and then you change the sign. If the gradient of line 1 is -1, so -1 is the same as -1/1. So that means the gradient of line 2, you just invert and change the sign. The gradient of line 2 will be +1/1. So, but before you even write all this, you just need to mention that the gradient of line 1 multiplied by the gradient of line 2 is equal to -1 if lines are perpendicular. Okay, I am done with gradient. Now, equation of the line. You also need to remember equation of the line. So equation of the line, this one is given by y is equal to mx plus c. So now where m is your gradient and then c is your y-intercept. So remember, we have x-axis as well as y-axis. Any point that cuts along this line, along this line, that is your y-intercept. And you need to remember that along this line, x is always equal to 0. So your y-intercept, x is always equal to 0. Any point that cuts along this line. So if they give you the coordinates of r, if you are looking for coordinates of r, and r is your y-intercept, you already know, at r, that means x is equal to 0. And then you will take that 0 and substitute in your equation. You will always get the corresponding y value. Now, you can use y is equal to mx plus c, or another formula that you can use is y minus y1 is equal to the gradient into x minus x1. That is another option for finding the equation of the line. So now, again, you need to notice that from the equation of the line, you must be able to read the gradient as well as your y-intercept. Sometimes in the exam, they will give you the equation of the line that is not written in a standard form. So if I'm if you are given any equation of the line that is not written in a standard form, for example, they will give you maybe 3y minus 2x minus 1 is equal to 0. So if you are given any equation that is not written in a standard form, I recommend that you write this equation in a standard form first. So this is the same as 3y is equal to transpose 2x transpose 1. Now you divide everything by 3. So if you divide everything by 3, you will have y is equal to 2 over 3x plus 1 over 3. Now, from this equation, you can now read your gradient. Your gradient is 2 over 3. From this equation, you can read your y-intercept. Your y-intercept will be 0 and 1 over 3. So if they give you any equation that is not written in a standard form, before you do anything, write that equation in a standard form so that you can read your gradient. You can also read your y-intercept from that equation. We also have point of intersection. Sometimes they will give you, or they will not even give you, they will ask you to find the equation of the line AC. Ask you to find the equation of the line AB. And then thereafter, if you have the equation of the line AC as well as the equation of the line AB, you can now calculate the coordinates of A, because A is the point of intersection of these two lines. Sometimes in the exam, they are very harsh. They will not even ask you to find the equations of this line. They will just go straight and say, determine the coordinates of A. But if you see that you can find the equation of AC, and you can find the equation of AB, and you can see that A is the point of intersection, so you will find these two equations and then equate them. And then if you equate them, you will be able to find the coordinates of A, which is the point of intersection. So when you equate them, so this is px plus k is equal to mx plus c. When you equate them and solve for x, when you equate them, you'll solve for x and you'll get x maybe is equal to whatever number. And then to get the corresponding y value, you can take this x and substitute in this equation, or substitute in that other equation. You'll decide, you'll choose one. You will always get the y value. Now, calculate the size of an angle. So I think already above, I did speak about calculating this angle theta. So I said to calculate this angle theta, we need to have a gradient of this line. So because theta is an angle of inclination, so to find tan theta, we just say tan theta is equal to the gradient. And then theta will be arctan of that gradient that you will calculate. And then you will get this angle theta. To find this angle beta here, so you will notice that angle beta is the angle of inclination of a line that has a negative gradient. So this line here is negative. So now to find angle beta, you'll say tan beta is equal to gradient, and then your beta will be arctan of that negative gradient, and then you just add 180, because if the slope is negative, you must add 180, and then beta will be an angle that is bigger than 90. And then sometimes they will also ask you to find the angle that is not even an angle of inclination. So this angle here. So if you are looking for alpha, you need to remember now, if you look at this triangle, here is a triangle that is formed here. Now you will notice that this angle theta, because this one and that one, they are the same because of vertical opposite angles. This angle theta plus this angle alpha is always equal to beta, exterior angle of a triangle. So if you are looking for this angle here, angle alpha, it will be always alpha is equal to beta minus theta. That is exterior angle of a triangle. Same story with this one. So angle theta, angle of inclination, plus angle alpha is always equal to this exterior angle, which is another angle of inclination. So again, alpha will be always equal to beta minus angle theta. That is exterior angle of a triangle. So you will see when we are doing questions. So for now, I'm just explaining the basic things that you need to remember before you even attempt any analytical geometry question. With this information, there's no way that you will fail part 1 of analytical geometry, which is around 20 marks. Now, what is it that you need to remember again? The area of shapes. So you must be able to calculate the area of a triangle. So there is a triangle that is not a right-angled triangle. So if a triangle is not a right-angled triangle, you need to remember the area rule. So the area rule, if I have these two sides and the angle that is in between, the angle must be included to use area rule. So the area is 1/2 multiplied by AB multiplied by AC, and then sine of an included angle, so which is sine theta in this case. So that is for a triangle that is not a right-angled triangle. But in a triangle, if you can measure your height, which must be always which must be perpendicular to base always, ne? So if you know your height, you can use a half base multiplied by height. So here is our base in this case, which is BC, and then our height is H. So if the height is known, so your area will be half base multiplied by height. Even here in this triangle, if you can construct your height, which will be perpendicular to base, so your area will be 1/2. Here is your base, BC, and then your height is H, so it half base multiplied by height. Maybe also the area of a circle. So if you have a radius and then you have a circle, so the area of a circle is given by pi r squared. So I think that one is straightforward. Sometimes you need to know also the area of a trapezium. The area of a trapezium is given by half, and then the sum of the parallel sides. So in this case, the parallel sides are AP as well as CD. So that is why we have AP plus CD multiplied by the perpendicular height. So here is our perpendicular height. And then from these, you will always get the area of a trapezium. And then now, I think I have discussed basic things that we need to know. And then now we can go straight to questions. So I will do maybe 3 different questions. And then from there, I will go straight to part 2 of analytical geometry. So now let's go to question number 1. First question. In the diagram below, A is -1 and 0. B, we are not given the coordinates of B. C is 2 and -2. And D, we are not given the coordinates of D. Are the vertices of the trapezium having AB parallel to DC? Remember, if lines are parallel, their gradients are equal. The length of DC is 3 times the length of AB. So DC is equal to 3AB. ADC is equal to theta, so angle ADC is theta. E, which is 2, and 2 is the midpoint of AD. The angle of inclination of DC is alpha. Okay. Before you attempt questions, make sure that you read and understand the statement first. Do not just rush to answer the questions without understanding the statement. So let's start with number 1 here. So number 1, we are required to calculate the coordinates of D. Now, if you can check line AD, you can see that we have the midpoint as well as one end point. So we can always split the midpoint formula. So we can write this as, or we can write our midpoint formula as x for midpoint. So it will be xe in this case is equal to xa plus xd over all over 2. Now, what is the x value for midpoint? The x value for midpoint is 2 is equal to, what is xa? Xa is minus 1 plus xd all over 2. And then we cross multiply. We are going to have 2 multiplied by 2, which is 4, is equal to minus 1 plus xd. So that means xd is equal to 5. Now we also need to calculate yd as well. So again, we are going to have y value for midpoint. So the midpoint is at E, is equal to ya plus yd. So now what is ye? Ye is given us 2 as well, is equal to, what is ya? Ya is 0, and then plus yd all divided by 2. If we cross multiply here, we are going to have 4 is equal to 0 plus yd. So our yd is equal to 4. Therefore, the coordinates of D are 5 and 4. Okay, we do have the coordinates of D as 5 and 4. Question number 2. Calculate the size of alpha. So in the statement, we are told that alpha is the angle of inclination of DC. Now, so if alpha is an angle of inclination of DC, we know that tan alpha is equal to the gradient of DC. That means now we need to first find the gradient of DC. So the gradient of DC will be YC minus YD over XC minus XD. So this will be equal to, what is our YC? Our YC is minus 2 minus our YD is 4. All divided by our XC is positive 2 and then minus 5. So this is the same as positive 2. Now, therefore, we are going to have tan alpha is equal to positive 2. So alpha is equal to arctan of 2. So what is arctan of 2? So it will be 63.4, because we are told to round off to 1 decimal place. So our answer will be 63.4. So that is our angle alpha. So this is our number 2. Let's move to question number 3. Determine the equation of AP in the form of y is equal to mx plus c. Now, we are looking for the equation of AP. We said the gradient of AP is the same as the gradient of DC, which is equal to 2, because these two lines are parallel. So if lines are parallel, their gradients are equal. So now, we know that the equation will be y is equal to mx plus c. Our m is 2, x and then plus c. To calculate the coordinates of c, we do have one point that lies on line AP. So it is point A. So now, at point A, our point A is -1 and 0. So instead of y, we just put a 0, because y is 0, is equal to 2 multiplied by -1 plus c. Now transpose this -2, it will be +2 is equal to c. Therefore, our equation will be y is equal to 2x and then plus c. C is 2. So that is our equation of the line AP. So it is 2x plus 2. Okay. And then number 4. Number 4. Okay, let me write it here. Number 4, we are required to calculate the size of angle theta, correct, to 1 decimal place. Now, you will notice that angle theta is in this triangle here. So if angle theta is in this triangle, so we already have angle alpha. If we can find this angle here, if we can find this angle, which is angle DAO, if we can find angle DAO, and then we can use exterior angle of a triangle, because this plus that is equal to angle alpha. So exterior angle of a triangle. So now, for us to find angle DAO, we need to use DAO is angle of inclination, so we can calculate gradient first, and then we will find an angle. So we need to calculate the gradient of AE or the gradient of AD. So now, if we say the gradient of AE, the gradient of AE will be 2 minus 0 over 2 minus into minus 1. So this will be 2 over 3. And then from here, we can find an angle. So our angle will be tan angle DAO is equal to 2 over 3. And then arctan of this, we will get our angle as DAO as 33.7. So we are getting 33.7. Now we can calculate our angle theta. So we'll just say alpha minus 3,7, and then we will get our angle theta. So therefore, theta is equal to 63,4 minus 33,7. This is exterior angle of a triangle. Now, 63,4 minus 33,7 will give us 29.7. So the final answer is 29.7. That is our angle theta, exterior angle of a triangle. And then we need to move to the last question, which is 5 marks. That is question number 6. Now required to calculate the coordinates of B. Now we need to remember we have found the equation of this line. So we said it is y is equal to 2x plus 2. So now remember the equation of the line represent all the points that lies on that line. So that means I can write, remember the coordinates of B can be written as, it is x and y, right? Coordinates of B, it is x and y. So I can write my B as x, and then y. My y is what? Is 2x plus 2. I can write the coordinates of B as, yes, it is x, and then here I can just put 2x plus 2. That is my y. Now, there is something that I was told in the statement, that DC is equal to 3AB. So if DC is equal to 3AB, I can use that. I can now say DC is equal to what? 3AB. So now I can start by calculating the distance of DC first, or I can just substitute here. It is also fine. So now if I start by calculating the distance of DC, the distance of DC, let me just substitute straight. So the distance of DC will be XD. So XD, we got it as 5 minus XC, so it is 2 all squared, plus YD. YD, we got 4, and then it will be minus into minus 2, so it will be plus 2 all squared. That is your distance of what? Of DC. This is equal to 3. And then what is the distance of AB now? So the distance of AB is square root of, okay, XB. What is XB? So our XB is X, so it will be X minus, what is XA? So XA is minus 1, so it will be plus 1 all squared. And then plus, what is YB? YB is 2x plus 2, and then minus 0 all squared. All right, so now if I calculate my left hand side, okay, 5 minus 2, it is 3 squared. That will be, oh, here I did not put, okay, let me fix this a little bit. So it is plus, it is plus 2 here, so all squared. Let me just put this in the calculator so it will be quick. So we have 5 minus 2 all squared, and then plus 4 plus 2 all squared. So it gives us 3 root 5. So we have 3 root 5 is equal to 3 square root of, we have x plus 1 all squared plus 2x plus 2 all squared. And then we can divide by 3 on both sides. So 3 and 3 will divide each other. And then we square on both sides. So if I square on both sides, okay, let me square. If I square on both sides, remember 3 and 3 is gone. So I will have 5 is equal to, now squared will remove the square root. So I will remain with x plus 1 all squared plus 2x plus 2 all squared. And then now I can remove the brackets here. So I have 5 is equal to, this will be x squared plus 2x plus 1 is equal, or plus, this one will give me 4x squared, and then 2x times 2 is 4x times 2 again, so it will be 8x, and then plus 4. Now I can write this in a standard form. So if I write this in a standard form, x squared plus 4x squared, it is 5x squared. And then 2x plus 8x, it will be 10x. This is plus 10x. 1 plus 4. 1 plus 4, it is 5. Minus 5, because I am going to transpose 5 again. So it will be 0. So we can take out the common factor here. The common factor is 5x. So if I take out the 5x, I will remain with x plus 2 is equal to 0. So that means x is equal to 0, or x is equal to negative 2. But now, if we check our diagram, there is no way that x will be 0 at point B. So that means this one is not applicable. So the x value here is minus 2. So that means the coordinates of B, therefore, the coordinates of B are, our x is minus 2, and then our y, remember our y is 2x plus 2. So it will be 2 into minus 2, and then plus what? Plus 2. Now, that means our B is minus 2, and then this will also give us minus 2. So the coordinates of B are minus 2 and minus 2, or negative 2 and negative 2. So, and then we are done with this question. Let me move to the next one. Number 2, in the diagram K minus 1 and 2, L, we are not given the coordinates of L, and 1 and minus 1 are the vertices of a triangle KLN, such that LKN is equal to 78,69. This angle here is 78,69 degrees. KL intersects the x-axis at P. We already know here we have x-intercept, so therefore we know that y is equal to 0 at P. KL is produced, so that means the line is extended. The angle of inclination of KN is theta. So the angle of inclination of this line, we know it is angle theta. The coordinates of M are minus 3 and 5. Okay, and then now let's check the questions. So the first question here is, calculate the gradient of Kn. So we do have the coordinates of K, we do have the coordinates of N. So we can just use the gradient formula, changing y over changing x. So the gradient of Kn will be yk minus yn over xk minus xn. And then substitution. So what is yk? Yk is 2 minus yn. So it will be into minus 1. all divided by xk. So xk is minus 1 and then minus 1. So this will give us negative 3 over 2. Now we do have our number 1, so which is written as 3.1.1 here. So the gradient of kn is minus 3 over 2. Question number 2. Calculate the size of theta, the angle of inclination of kn. So number 2, which is 3.1.2 here. Now, okay. So angle of inclination. So we know that tan theta is equal to the gradient of kn. So we are going to have tan theta is equal to, the gradient of kn we got minus 3 over 2. And then we know that if the gradient is negative, we will always add that 180. So our theta will be tan, tan, and then we have negative 3 over 2, and then because the slope is negative, we just add 180. Or you can just ignore the negative sign, and then the answer that you are going to get, you will subtract it from 180. This is equal to, so it gives us 123.69. So this is 123.69. So this angle here is 123.69. Question number 3, which is 3.2 here. So question number 3. We are required to show that the gradient of KL is equal to 1. Now, you will notice that if you check the line KL, we only have one point that is complete, which is point K. We do not have the coordinates of P. We do not have the coordinates of L. But if we can find this angle here, which is the angle of inclination of KL, we can find the gradient. Now, we have just calculated the size of theta. So we can find this angle here using exterior angle of a triangle, because we have this and that. Now, that means angle, I can call it angle KPO. Angle KPO is equal to theta that I just calculated, which is 123.69 minus 78.69. This is exterior angle of a triangle. Now, this will give me 45 degrees. And then from here, I know this angle there, which is KPO, it is equal to 45 degrees. Now, I know that tan 45 degrees, 45 is an angle of inclination, is equal to the gradient of KL. So now, what is the gradient of KL? Tan 45 is the same as 1. So the gradient of KL is equal to 1. So we do have the gradient of KL. It is equal to 1. Number 4, which is 3.3 here. So number 4, which is 3.3, we are looking for the equation of the line KL in the form of y is equal to mx plus c. So now we do have the gradient of KL already. We do have the gradient of KL, which is 1. Also, we do have point K. We can use point K to calculate the value of C. So we know that y is equal to mx plus c. So y is equal to, our m is 1. We just calculated it, or we just proved it above. 1x plus c. Now, we are given point K. Our point K is minus 1 and 2. So it minus 1 and 2, or negative 1 and 2. Now instead of y we put 2, so we are going to have 2 is equal to 1 multiplied by into negative 1 plus c. Now this will give us negative 1, and if we transpose that negative 1, we are going to have 2 plus 1, which is 3. So c is equal to 3. Therefore the equation will be y is equal to x plus 3. So the equation of the line KL is y is equal to x plus, it is y is equal to x plus 3. Now, question number 3.4, we are required to calculate the length. We are required to calculate the length of Kn. So the length of Kn, we just use the distance formula. So we are going to have Kn, this is number 5, which is number 3.4 there. Kn is equal to the square root, and then it can be xk minus xn all squared plus yk minus yn all squared. Now, substitution. So let's check what is our xk. So our xk is minus 1. So this is equal to square root of gonna be negative 1 minus 1, because xn is 1. So all squared, and then plus, what is our yk? Yk we have 2, and then minus into minus 1, so it will be plus 1 all squared. And then now this will give us square root of, it is giving us square root of 13. So this is our Kn, and then again you get that 2 marks. Okay. Now number 6, which is 3.5.1. We are told now that Kn, if it is given that, we need to use this information that they are giving us. If Kn is equal to Lm, calculate the possible coordinates of L. Calculate the possible coordinates of L. So now let me go back to my diagram. So okay, let me erase here first. Okay. Okay. All right, so now Kn is equal to, so we have calculated our Kn, and then we got square root of 13, and then we are told it is now given that it is equal to Lm. Here is our Lm. Let me join this line. So here we also have square root of 13. Now calculate excuse me, calculate the possible coordinates of L. Now we need to remember, we also found the equation of this line. So we said the equation of the line KL is given by y is equal to what? Y is equal to x plus, it is y is equal to x plus 3. Now, remember the equation of the line represent all the points that lies on the line KL. So now, That means I can write my L as, here is L. I can write L as, our X will be X, and then our Y is X plus 13. Now, I am given the distance of LM, so I'm going to use distance formula. So, now, the distance of LM is equal to the square root of, okay, is equal to the square root of, it will be, okay, square root of XM or XL minus XM all squared plus YL minus YM all squared. So now our LM is root 13 is equal to, and then square root of, and then here I am going to have, what is my XL? My XL is L minus, what is my XM? It is negative 3, so minus into minus, it will be plus 3 all squared. Plus, what is my YL? My YL is X plus 3, not 13. So it is X plus 3 here. So we got X plus 3. And then minus, what is my YM? It is minus 5. So it will be plus, it will be plus 5 all squared. And then we can square on both sides to remove the square roots. So if I square on both sides, the square roots will cancel. So I will remain with 13 is equal to, now I have X plus 3 all squared plus X plus 8 all squared. And then again, I can remove these brackets. So we have 13 is equal to, this one will be X squared plus 6X, and then plus 9. So, and then second bracket will be, if I remove it, I will get, this is plus X squared plus 16X, and then plus 64. And then I can write this equation in a standard form. So if I write it in a standard form, X plus X, X squared plus X squared is 2X squared. 6X plus 16X, it is 22X plus 22X. And then 64 plus 9, 64 plus 9, okay, here is 64, and then plus 9, and then minus 13, it is 60. So this is plus 60. Now we can simplify it. This is equal to 0. We can divide by 2. 2 is common throughout. So we are going to have X squared plus 11X plus 30 is equal to 0. And then we can factorize this. Factors of this is equal to 0. Factors of 30 that can give me 11 when I add, it is 5 and 6. So we have plus and plus. Now, okay, that means our X can be minus 5, or our X can be negative 6. Now we take this minus 5, or we take this negative 5, we substitute there. So we are going to have minus 5 plus 3. So minus 5 plus 3, it is negative 2. So the coordinates of L can be, okay, it can be minus 5 and negative 2, or the coordinates of L can be minus 6, and if I put minus 6 there, I'll get minus 3. These are possible coordinates of L. So it can be this one or that one. That is why they said possible coordinates. It is possible that it is minus 5 and minus 2, or minus 6 and minus 3. Okay. Now, okay, let me check the question that follows. Three point 5.2, it is our number, I think. Okay, I think this will be our number. Now the next question is calculate the coordinate of L if it is given that KLMN is a parallelogram. So here I have already joined the vertices. So now you need to remember that for any parallelogram, diagonals bisect each other. So that means that they are sharing the very same midpoint. So we can calculate the midpoint here using a K and M. So the midpoint of KM, which is the same as the midpoint of LM, because diagonals bisect each other. So the midpoint will be, okay, here is the midpoint. Okay, let me write it here. The midpoint will be minus 1 plus into minus 3 over 2. And then for the y value, we are going to have 2. We are going to have 2 plus into minus 5 over 2. And then that means that the coordinates of M are negative 2 and negative 3 over 2. Now we do have the coordinates of M. So we can split the midpoint formula to find the coordinates of L. Now we can say x value for midpoint. What is the x value for midpoint? X value for midpoint is negative 2. So negative, okay. X value for midpoint is negative 2. So we have negative 2 is equal to XL, the x value that we are looking for, plus xn, which is 1 all over 2. So now we are going to have 2 multiplied by negative 2 minus 4 minus 1. So XL is equal to negative 5. And then y value for midpoint is negative 3 over 2 is equal to YL plus YN, which is minus 1 over 2. Now with this one, 2 and 2 can just cancel out, and then you transpose that negative 1, it will be plus 1. So that means YL is equal to negative 2. So the coordinates of L are minus 5 and minus 2. That means even from above, from the question, from question 3.5.1, which is our question 6, we know that, the coordinates of L are minus 5 and minus 2. So we know that L is -5 and -2. Now, the next question is, I think this is the last one now. So I think it's question 8, but which is 3.6 here. The last question is, T is the point on KL produced. So since the line KL is extended, so if we extend the line KL, we then notice that, okay, there is a point. So I can put it here maybe. Okay, here is the point T. So it is on this line produced, such that TM is equal to LM. Oh, so these lines are now equal. Okay, let's see. Okay, so here is the line that they are talking about. Okay, now, so this one and that one, they are equal. Calculate the area of triangle KTN. Okay, let's see the triangle that they are talking about. KTN. Okay, let me just join T and N so that I'll see the triangle in question. Okay. KTN. All right. Here is the triangle. So now you'll notice that with triangle KTN, let me highlight it maybe. Here is the triangle KTN. So you'll notice that with KTN, we already have one side, which is square root of 13. We did calculate it. We also have an angle. So if we can calculate the length of KT, we can find the area. We just need to find the length of KT. So now remember, since these two sides are equal, they are both equal to root 13. So that means these coordinates that we are calculated here, which is -6 and 3, because now we have seen that, we have noticed that -5 and 2 belong to L. So that means these coordinates, which is -6 and -3, are actually the coordinates of T. So T is -6 and -3. Now we can calculate the length of KT. So here the length of KT will be, okay, let's see the distance of KT. So let me erase here so that I'll get enough space. The length of KT now. So KT will be the square root of xt, which is -6, minus into -1, so it will be +1 all squared, plus -3 -2 all squared, and then it will give me a square root of 50. So this one here gives me a square root of 50. Okay, and then now that means the area will be 1/2, and then the side is KT, so it will be root 50 times square root of 13, sine of an angle, sine angle 78,69. So if I calculate, okay, I get area as 12,5 unit. All right, in this question, we are given ABCD, which is a parallelogram. So you need to remember all the properties of the parallelogram. Opposite sides are parallel, opposite sides are equal, diagonals bisect each other. So AC as well as AD, they are sharing the same midpoint. We are told that A is 0 and 4. B is -6 and -2. C is X and Y. And D is 10 and -1. F, G, and H are x-intercepts. So remember, at the x-intercept, Y coordinate is always equal to 0. At the x-intercept, so that means here at F, we know the Y value. Here at G, we know the Y value. Here at H, we know the Y value. The Y value will be 0. E is the point on the x-axis to the left of F, and J is the point on the x-axis to the right of H. Now, the first question here, we are required to calculate the gradient of AB. So gradient, you just write the formula, change in Y over change in X. Fortunate enough, we are given the coordinates of A, we are given the coordinates of B. So the gradient of AB will be YB minus YA over XB minus XA. And then it goes straight to your substitution. So what is our YB? YB is -2 minus what is our YA? YA is +4. All divided by XB is -6 and then minus 0. So the gradient here will be +1, and then you get that 2 marks. Question number 2. This is number 1. Question number 2. We are required to find the equation of the line CD. Equation of CD. Now remember, we are told that this is a parallelogram. For CD and CD and AB, they have the same gradients. So we already know that the gradient of CD is equal to the gradient of AB because these two lines are parallel. Now, the equation of the line is given by Y is equal to mx plus c. But we do have our m. The gradient is equal to 1 because the gradient of AB and the gradient of CD are equal because these two lines are parallel. So it will be 1x plus c. Now to calculate the value of c, we just need one point that lies on line CD. We do have point D. So we take point D and substitute here. So at point D, you can even write D, which is 10 and -1. So our Y is -1 is equal to our X is 10. So we are going to have 10. We need to substitute 10 and then plus C. We transpose 10. So we are going to have -1 minus 10, which will be -11 is equal to C. So therefore, the equation here will be Y is equal to X minus 11. So you get that 3 marks. Okay, so here is our equation of CD. Now, the question that follows, determine the coordinates of M, the midpoint of AC. Now, we are looking for the midpoint of AC, but we do not have the coordinate of C. But we are told this is a parallelogram. We know that M, which is the midpoint of AC, is the same as M, which will be the midpoint of BD, because diagonals bisect each other. So if diagonals bisect each other, that means that they are sharing the same midpoint. Now, we are going to use the coordinates of B and D. So the midpoint is given by, it is x1 plus x2 over 2, or xb plus xd over 2. So in this case, it will be minus 6 plus 10 over 2. And then for the y value, it will be minus 2 plus into minus 1 over 2. So the midpoint of AC, which is also the midpoint of BD, is the same as 2 and negative 3 over 2. So it is the same as 2 and negative 3 over 2. Calculate the coordinates of C. So now we are looking for C. So for line AC, we already have the midpoint. For line AC, we know that AM is equal to MC. So we can use midpoint formula again, but we are going to split it. So we will say Y, let me start with X. We'll say X midpoint, the X value for midpoint, is equal to, it is given by XA plus XC over 2. Now, what is the X value for midpoint? So we calculated our X value for midpoint as 2. Here is it. Is equal to XA. XA is 0 plus our XC all over 2. And then here we multiply everything by 2, or we cross multiply. So we are going to have XC is equal to 4. So XC, we do now have the coordinate of C, which is 4. Now for Y, we are going to do the same. So we are going to have Y for midpoint is equal to YA plus YC all over 2. So we have the Y for midpoint as minus 3 over 2 is equal to, we do have our YA is positive 4. So this will be 4 plus YC over 2. Now we multiply everything by 2. So if we multiply negative 3 over 2 by 2, we'll get a negative 3 is equal to 4 plus YC. So therefore, transpose for our YC will be negative 7. So now we do have the coordinate of C. So the X value is 4, and then the Y value is negative 7. So the coordinates of C are 4 and minus 7. Okay, that was number 3. No, it was number 4. So the coordinates of C. And then the last question now, we are required to calculate, we are now required to calculate the size of BCD. So we are looking for this angle here, BCD. So here is our BCD. So we are looking for this angle. Here is our angle BCD. Now, this question is 6 marks. We need to find that angle. Now here we can find, we can find the angle of inclination first. So we can extend this line so that we can see our angle of inclination. And then even here we can extend so that we will see the angle of inclination. So we can calculate this angle here. We can also calculate the angle that will be formed there. And then use this triangle. So my lines are not straight. Let me make them straight so that it will be clear. So let me see if I extend here. Okay. Okay. So even here I can extend. So that I'll be able to calculate the angle of inclination. Okay. Now, we are going to use this triangle to find the angle that we are looking for. Here is this triangle that I'm going to highlight. Is this triangle. Now, you can see that if we can find, if we can find this angle here, which is the same as that one, as well as this angle here, which will be an exterior, and then we will be able to get the angle that we are looking for. Let me call this one angle. Fortunate enough with paper 2, they will give you diagrams. So let me call this one angle theta, and then let me call this one angle alpha. Now remember, we calculated the gradient here, and we said the gradient is equal to 1. So we can find that angle theta there. We can say a tan theta is equal to, what is tan theta? Our tan theta will be 1, and then arctan of 1 will be 45. So this angle here is 45. Now we need this one. We need the angle of inclination of the line BC. Unfortunately, with BC, we do not have gradient, but we can calculate gradient. So the gradient of BC will be YC. Our YC, we calculated it as -7. Minus YB, it is minus 2. So it -7 minus into -2, all divided by our XC. We said our XC is +4. So we have 4 and then minus into -6. So the gradient of BC will be -1 over 2. We are getting -1 over 2. And then we can find that angle alpha there. So our angle alpha will be, remember, if the gradient is -1 over 2, and then you just plus 180. So alpha will be, if I calculate it, I'm getting 153, it is 153, calculator, 43. Now we can just say, therefore, the angle that we are looking for, therefore BCD is equal to 153. BCD is 153 minus 45, which will give us 108,43. So the angle is 108,4. We are given the quad AEBC. So in this quad AEBC, we are given the coordinates of B. We are also told that G, O, and F are x-intercepts. Remember, at the x-intercept, y is always equal to 0. Now, we are given H, which is 1 and minus 4. We are told that H is a point on line AC. Now, that means A, H, and C are collinear. So we are given angle ABC. So that is angle B, which is equal to theta. And then we are also given the area of triangle OPF, which is equal to 12 square units. We are also given the angle of inclination of line AB, which is 45 degrees. We are also told that HC is equal to 2AH. All right, now, in the test or exam, make sure that you read and understand the statements. Make sure that you read and understand the statement. Do not rush to questions without understanding the statement. So now, let's check question number 1 here. Question number 1 here, we are required to calculate the length of BF, or the distance formula. So BF is equal to, and then the distance formula, it is XB minus XF all squared plus YB minus YF all squared. And then the next thing is substitution. So the length will be, what is XB? So XB is 3 minus 5 all squared plus, what is YB? YB is 4 minus YF. YF is 0 all squared. And then calculator will give us 2 root 5. So that is the length of FB or BF. So it is 2 root 5. That is question number 1. Let's check question number 2. So question number 2 here, we are required to calculate the gradient of BF. So again, with the gradient, so we will write the gradient formula. So we denote the gradient using small letter m. So the gradient of BF is equal to YF minus YB all over XF minus XB. And then the next thing is substitution. So now what is YF? YF is 0 minus, what is YB? YB is 4. All divided by, what is XF? XF is 5. And then minus, what is XB? XB is 3. Yes, XB is 3. So this is equal to, now if we calculate here, we are going to get, calculator will give us the gradient of BF as negative 2. So that is the gradient of BF, or the gradient of FB. Question number 3, calculate the size of theta. Now let's go back to the diagram now. you will see, or you will notice that angle theta is in this triangle BOF. Now, and then in that triangle BOF, we already have an angle that is equal to 45 degrees. So there is an angle there which is equal to 45 degrees. And then we can also calculate the angle of inclination of BF. So we can get the angle of inclination of BF. So let me call this angle alpha. So now we do have the gradient of the line. So number 3, we can just say tan alpha is equal to the gradient of the line we just calculated. It is -2. So that means alpha is equal to shift or arctan of -2. Remember, if the gradient is negative, you always add 180. So now that means your alpha here will be, excuse me, your alpha here will be arctan of -2 plus 180. It will give us 116.57. So now, but we are not looking for alpha, we are looking for theta. So now we can see that in this triangle here, so this alpha is an exterior angle. So we can just say alpha minus 45, we will get that angle theta. So that means our angle theta, therefore our angle theta is equal to 116.57 and then minus 45. Minus 45, that is exterior angle of a triangle. Now, so our theta will give us 71.57. So we have 71.57. So our theta is 71.57. Okay. Now let's move to question number 4. Question number 4, we are required to prove that HF is parallel to AB. So we are required to prove that HF is parallel to AB. So now here is our HF. So if I can join H and F, and then I am required to prove that these two lines are parallel. Remember, if two lines are parallel, they will have equal gradients. If two lines are parallel, they will have equal gradients. So let me calculate the gradient of AB first. Now, you will notice that we do have the coordinates of B, but we do not have the coordinates of A. So we cannot use change in Y over change in X. But fortunate enough, we do have the angle of inclination. Now, if we have the angle of inclination, so this is our number 4. Let me put it here. So if we do have the angle of inclination, we can always say tan theta, or let me just say tan 45. In this case, it is 45. Tan 45 is equal to the gradient of AB. Now, what is tan 45? Tan 45 is the same as 1, so is equal to the gradient of AB. So that means the gradient of the line AB is equal to 1. Now, I need to calculate the gradient of HF. Fortunate enough, with H and F, I do have the coordinates. So I can use the formula change in Y over change in X. Now, the gradient of HF is equal to YF minus YF minus YH all over XF minus XH. And then now substitution, what is YF? So YF is equal to 0 minus, what is YH? It is minus 4, so it will be minus into minus 4, all divided by 5 minus 1. So here again we are getting the gradient of HF as 1. Now we can see that these two gradients are equal. So we will write that the gradient of AB is equal to the gradient of HF. So therefore AB is parallel to HF. So therefore we know now, we see these two lines are parallel. Let me indicate these two lines are parallel. So okay, so these and that are parallel. So we are done with number 4. We have proved that lines are parallel. So let me put this in my diagram. So we have 2 root 5. And then what else? We have the gradient of what? Of GF. Okay. As minus 2. And then we calculated the angle. Theta as 71,57. So maybe I can say this is 71,57. Now, let's move to question number 5. Okay, let's see. Question number 5. It is further given that BC. So let me check BC here. Where is BC? Not BC. Oh, it's EC. So it is further given that EC. So they are talking about the line EC. Bisect AB perpendicularly. So now, if we draw a line here, okay, I'm not sure if I will be able to get the straight line that I am looking for. Okay, if we draw a line here, so the line that I have drawn, it will bisect. Okay, it will bisect the line AB at 90 degrees. So bisect this and that will be equal pieces. Because bisect means you are dividing into 2 equal parts. Now, the question is, if the line bisects perpendicularly, what type of quad is AEBC? So now you can see that the longer diagonal bisects the short diagonal at 90 degrees. So we have a kite. So the answer for 4.5 the answer we have 4.5. It is a kite. Why? You can mention that a long diagonal bisect short diagonal at 90 degrees. So this is a kite. This is a kite. Okay, it's 90 degrees. So let me erase here. Okay. Now, let's move to question number 6. Hence or otherwise, calculate the length of AC. So we are looking for the length of AC now. Okay. Remember here we said these two lines are parallel. Now, if we look at the information that we have, we are told that HC is equal to 2AH. So here I can just, here at AC, I can put 2AH. Okay. And then we know, we'll see this is what? This is AH. Now, again, we have calculated the length of BF. We have calculated the length of BF as 2 root 5. We have also proved, that this line and that one, they are parallel. So we can use a proportionality theorem. So here we are looking for AC. So we can say AB, not AP, but we can say BC over BF is always equal to AC over HA or AH. So why? This is a prop theorem. You just write a prop theorem. Remember, if you are using this resin proportionality theorem, you need to mention lines that are parallel. We have proved that AB is parallel to HF. So we can use proportionality theorem. Now, what is our BC? Okay, we do not know our BC. We can calculate it. So we are going to have BC over, we do have our BF as 2 root 5. This is equal to, what is our AC? So our AC is AH plus 2AH. So it will be 3AH over, what is our AH? We can keep it as AH. Now, you'll notice that AH and AH will divide. So now, and then we cross multiply. We are going to have our BC as 6 root 5. Now, if our BC is 6 root 5, remember, we said this is a kite, and we know that with a kite, adjacent sides are equal in length. So that means BC is the same as AC. So BC is the same as AC, which is equal to 6, which is equal to 6 root 5. So we have calculated our BC, which is the same as AC, which will be 6, which will be 6 root 5. Okay, let's move to the next question. Okay, the next question here. We are now required to calculate the area of AOFC. AOFC. Now, AOFC, we are looking for the area of this shape. We do not even know what this shape is. So it's AOFC now. But what is it that we need to remember here in the statement, we are told that the area of this triangle here is 12 units squared. Now, if we can calculate the area of triangle ABC, so if we can calculate the area of this triangle as a whole, here is this bigger triangle, and remove this 12, we will remain with the area that we are looking for. So now let's calculate the area of a bigger triangle first. How are we going to calculate it now? Okay, let's see what is it that we have. So for triangle ABC, okay, triangle ABC is an isosceles triangle. So we did get our angle theta. We said our angle theta, it was 71,57 if I'm not mistaken. So we calculated the length of this side as 6 root 5. Even this one is 6 root 5. So since this is an isosceles triangle, even this angle here will be 71,57. Now, we have two sides, but we do not have the angle that is included. Remember, if you want to use your area rule, so you must have two sides as well as the angle that is included. But we can calculate the included angle using some angles in a triangle. So the included angle here will be 180 minus 71,57 minus 71,57. So our included angle will be, what is 180 minus 71,57 minus 71,57. So our angle is 36,86. So we are getting 36,86. So this angle here is 36,86. Now, we can calculate the area of this bigger triangle now. Triangle ABC. And then we are going to remove the area of this. So remember, we are given this area as 12. And then we will remain with the area of the shape that we are looking for. So the area will be area of triangle ABC will be 1/2, and then 6 root 5 multiplied by 6 root 5, and then sine of an angle that is included, so which is 36,86. Now, this will give us a calculator, will give us 53.99, so which is approximately, I can say this is 54 units squared. So that is the area of triangle ABC. Now, so from that you can just say, therefore, the area of the shape that we are looking for is AOFC is 54 minus 12. So what is 54 minus 12? It will be 42 units squared. And then we are done with this question. So this question was 19 marks. And then we are done with this question. So let's move to the next question.